All right, let's do it. Okay. I was just thinking, you know how next term, oh, you have some great news. Oh, here we go. When do you get your advanced marks? That's what I want to know. Quang and Greg have expressed interest. What? Are you serious? Messaging Miss Sankey right now. Is that too loud? I'm sending a picture of that. All right, I'll await to see what she says. I'll let you know if she messages me. That's exciting. Anyway, what I was going to say about extension 2 is it's going to be a little bit frustrating for you because you would have done your HSC by now, so you'd kind of be finished, and then we could just start extension 2 fresh, but you're still going to be revising extension 1 whilst doing extension 2, so that's kind of annoying for you. But yeah, when you get your advanced marks, that's what I want to know, because your response looks really good. Anyway, okay. Combinatorics is what I hate. I reckon this is my least favorite topic. Just because it's so confusing. I find it confusing. Anyway. Alright. Using this identity, show this. Okay. Don't know. Yeah, that sucks. So, when I first saw this, I kind of thought, well, I don't know how I'd get that. But then, if you just kind of consider, just forget this existed for a sec. If you expanded this using the binomial theorem, then you would have a term that has this as the coefficient, and kind of the same principle. These are to the power of n, and our highest power here, sorry, our highest combination is n. So I'd be thinking if you expand this, you might end up with this term and this term, and because I'm expanding it twice, I'll end up with squareds. So I guess the tactic in this one would be to expand this, find your term that has this on it, and then expand to this, find your terms that also have this on it, and equate them. That was kind of, I guess that's kind of the tactic. And then because they've given us an identity, and then they've asked us a bunch of questions to do with like grouping and stuff, and the fact that there's a show this, which is this, it's probably going to be the case that everything's going to relate to this identity. So I guess we need to do that. So I'm going to expand this and then expand this and pretty much see what happens. 16i. Okay, so I'm going to expand 1 plus x to n. And we probably don't, yeah, I guess we do because we need to find the term. So if I were to expand that, and I'd just like to write binomial theorem, I'm going to use 2n. It's the sum 2n to 0 of 2n k a to n minus k b. Okay, so we're looking for the term where that's an n, and for that to be, because that's what I'm trying to prove, for that to be an n, that would mean this needs to be an n. 2n minus n, that's going to be a to the power of n, but my a is 1, so really this doesn't matter. I'm looking for this term where that's to the n, which is an x. So basically I'm looking for my xn term, and well, that's it. I know that that term is going to be 2n 0, 1 to the power of, I don't care, but x to the power of, sorry, not 0, n, x to the power of n. So that's kind of the term that I'm, like my term of interest, I guess. So I don't really need to expand that. I have a term that has 2n on it, 2n, choose n. Now I want to be able to find the other term. So In other words, if I were to expand 1 plus x and is it that? 1 plus x n. I want to show that xn, its coefficient is going to be this thing. Can't even highlight it. That thing. If that makes sense. So I'm comparing the coefficients of this term. So I found that that's that. So now I need to find this. So that's my goal. So I actually need to expand this now, which is going to be kind of fun. But I've already kind of, well, I haven't actually done it at all, have I? Okay, so forget this exists for a sec. Put that in a blue circle. Okay, equals. I'm going to use massive brackets. Now, if I expand this thing using this, let me rewrite that with n's in it. That can go away. Okay, so my first term is going to be n choose 0. Then that's going to be, that's not a 2, is it? So that's n minus 0, which is just n. So 1 to the power of n, which I don't need to write. And then b to the power of 0. So x to the power of 0, which is also 1. So that's all just going to be 1. So I don't need to write that. My next term, n choose 1. Hope I'm making sense. Okay, that's going to be n minus 1. So x n minus 1. And this is going to be b 1. So x 1. And see how, actually, let's just keep going. Plus, I'll do another term. Yeah, I'll do another term. n2, x n minus 2, x 2, plus blah, blah, blah. Plus, what would the last term be? It would be n choose n, x n minus, no, 1. That's not an x, is it? That's a 1. They're 1s, aren't they? No. So 1 to the power of 0 and x to the power of n. Okay, email. Now put that twice. Let me copy that. Okay. Now, if I wanted to expand this, so obviously that's that set of brackets, and that's that set of brackets. If I want to expand this, the whole point of this was to find where xn is. Now, if I were to expand it, you can see that these terms don't give me anything. So like if I times this by this, that's just going to give me no and choose 0 squared. So that doesn't really help. But when I times this term by this term, see how I've got my xn there? And similarly, if I times this term by, maybe I should add another term, by it'll be the one less than that. I'm also going to have an xn term, because this would be n minus, let me do it. So if I also had n choose to be n minus 1, 1 to the, I don't know why I wrote all the 1s, but 1 to the power of something, and then x to the power of n minus 1. So you can see that when I times this by this, I get my xn term, and when I times this by this, I also get my xn term, because I've got that times that, which is that. And it's kind of like diagonals, if that makes any sense. So if I only consider the terms that are going to have xn in them, it's going to be, so n choose 0. I thought that was Sankey. It's not. N choose n, x, and that's the first term that has this in it. The next term, so many emails, notifications. My next term would be, so this one times this one. Forgot my plus sign there. So n1, x1, x, n minus 1. Plus, and then if I kept doing that, I'd end up with I guess if I just consider now my last term, which is this, be this one times this one again. So is that right? Yep. And x n. Is that right? I've missed stuff here. xn. Oops. This is my NO. I'm missing. It's probably n1. That was n minus 1. Okay. So if I then factorize that, so if I take the xn out, I've got. Ooh, why are you allowed to ignore? Oh, okay. I'm not ignoring it. I know that it all exists. That's okay. I'll put one in there. Now, isn't it meant to be a massive? Yeah. Now consider the xn terms. Okay, so I only care about the terms that have xn in them. You're right. There's going to be like, obviously this is infinite, so it's going to be like huge. I only care about the terms that have xn in them. So in doing that, I now have, okay, so I've got n, o, n, n, plus n minus 1, n, 1, plus blah, 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 plus n, o, n, n. Can you see that so far? So I've got all my terms are the coefficient of xn. See how my goal is to have n choose 0 squared plus n choose 1 squared plus blah, blah, blah. I've kind of got that, but I just need to, I guess, turn it into something that looks like that. And it comes from the property that now since comes from, is it Pascal's property? I think, no, it's just a property of, yeah, Pascal's triangle. So n choose k is the same as n choose k minus 1. So in other words, these two are identical, and these two are identical, and these two are identical, just from like the triangle, you know how these two are identical and the next two inside are identical. So I can rewrite all of this as n0, n0 plus n1, n1 plus blah, 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 plus n, which is xn, n choose 0 squared plus n choose 1 squared plus n choose n squared. And there we go. And therefore, 2nn equals n squared plus n1 squared. I think this is a pretty terrible 2 marks. You mean n minus k. What did I write? K minus 1. Whoops. Thank you. Just went to write it again. N minus k. Symmetry. It's symmetry. That's the property. I think it's this. Yeah. Okay. I hope that can make some kind of sense. Because they've given you that at the start of the question, and it assumes that you're going to use it. And you can tell that from the first part, you've got, see at the top of the combinatoric is 2n, and then the second part, the top of each of them are just n. I still don't get why you're allowed to ignore most of it. I haven't ignored it. Well, I have, but it's kind of like if I expanded a full set of brackets and I only cared about the x to the power of 2 term, and then I expanded a full set of brackets, and then there was another x to the power of 2 term. I'm just equating their coefficients. That's all I'm doing. So maybe that shouldn't say equals. Maybe that should be, this implies. Like this one. I haven't done that either. The xn term. Is that maybe better? You're right, I have ignored it, but it's only because I don't care about it. I hope that makes sense. Anyway, that took a full page of working out, so that's nice. I should probably write as required. And here I'd write equating coefficients. That makes more sense. Okay, sweet. Okay, now let's actually answer a question. A club has 2 N members, N women and N men. So it's a group, half of them are men, half of them are women. It consists of an even number of people, that makes sense. So 0, 2, 4, because the number of women and men have to be equal. Yeah, number of men and women equal. Show that the number of ways to do this is 2nn. So I guess what you'll notice is this is what we proved in the previous question, and they've given it to us. And so then if you just like think about this, I guess conceptually, just using this line, move that. You just think about this line. Pretend we've got a group of men. I know that there's n men, and my first group, let's suppose, so have a look at the groups. They consist of even numbers. The first group has no one in it. So if I have no one in my group, the first group's going to have n options, and I'm going to choose none of them. And that's going to be how I pick how many men are in that group. And how many women I pick in this group is going to be the same, and choose 0. Now my next group's going to have 2 people in it. I've got an n amount of people, and I choose 1 male. And then I have also an amount of girls, and I choose 1 girl. And then continues on until I have a group of 2n people. N of those are going to be men, and I'm going to choose all of them. And then n of them are going to be women, and I choose all of them. So that's essentially how I'm going to prove this. It's just a matter of actually writing it. So let me grab this. So if our men equal our women, and this group has no one in it, then the number of ways of choosing that is going to be, so this is a group of 0, so group of no one, then the number of ways to pick a man is going to be n of them, I choose none, n of them, I choose none, that's the women, and that's n 0 squared. If the men and the women are also equal, but they equal 1, so this is a group of 2, then the number of ways is, here's the men, there's n of them, I choose 1 of them, there's n women, I choose 1 of them, so that's n1 squared. I hope this makes sense. And blah, blah, blah. If the men and the women equal n, so this is a group of 2n, then the number of men, there's n of them, I choose all of them, there's n women, I choose all of them, and then there's that many ways of selecting the groups, and therefore we've got no squared plus n1 squared plus blah 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 plus nn squared, which we said was equal to 2nn, and that's from part I, and that's that as required. Was it a proof? Yeah, as required. I hope that makes sense. I think that's pretty easy to wrap your head around. I hope. It's the next two that are a little bit more interesting. Oh, I need another page. Okay. From the group chosen in part II, 1 of the men and 1 of the women are selected as leaders. So to show that, and I think this part's important, the even number of people, you choose them, and then you select a leader. So I have to kind of do it in that order. So if you just consider also notice that we don't have an n choose 0 term. I wonder what the marker criteria says with the line showing giving reasons. Yeah, giving reasons just means show you working out, but because I feel like you could have just done this in your head. That's a good point, actually. I wonder what the marking guidelines are. Should we look at that? The question is at 16. Oh, there is no. bland, isn't it? Where's it from? We'll find it. Oh, it's from last year's HSC. Okay. Question 14a. Whoa, what is this? That's I. Okay. Look at that argument. They've like written what we were talking about in words. Said, okay, the first term is going to be multiplied by the last term, which is, and then the n minus 1th term will be multiplied by the n1 term. Interesting. Oh, they've got or. Okay, maybe that was a better way of writing it. They've written the coefficient of xn in that expansion is this. The coefficient of xn in this expansion is this. Anyway, what were we doing? Yeah. Explains why one of the terms is that times that. That's it. So you're just explaining why one of them are equal to the other one. Is that literally it? And then provides a correct solution. Okay, there you go. So this would be enough of a justification for 1 mark. This would give you your second. Interesting. Okay. Oh yeah, so we're showing, we've got the same groups. So these are the same values. It's just a matter of choosing a leader. Now the n choose 0 term's not there because for the first group, there's no ways of choosing a leader. So you'd be multiplying by 0. I guess we should probably show that. So if I had a group, how am I going to write this? If I had no men and no leaders, what am I choosing first? What did I say? The even number of people and then the leader. So I've got to n choose 0 ways of choosing the men, and then there's no ways of choosing a leader. So then 0 women, 0 leaders, that's going to be the same. So that's why it's equal to n0 squared, 0 squared. So if I've got 1 man and 1 leader, then that's going to be, I have n of them, I choose 1, and out of that 1 person, that's my leader. So there's 1 way of choosing the leader. And then 1 woman, 1 leader, same. 1 squared. Is that making sense? The next one, 2 men. I'm still. Oh wait, these are 1. Is it 1 liter? And then, yeah, 1 liter. Not 1 liter. Liter. Is that right? 1 liter. Well, I can't because there's no. It's impossible to choose a liter. Okay, let's just leave that at 0. 1 man, 1 liter. 2 men, 1 liter. Is I've got n people, I choose 2 of them, and then how many ways are there to select a leader out of 2 people? Well, there's 2 ways because there's 2 people, and same with the women. Squared, 2 squared. Okay, and if I keep going, still good. Now we've got, whoops, n men, 1 leader. That's going to, something like that. That's going to be n men. I choose n of them, and then because it's n people, I can choose n different leaders. Because that's essentially n choose 1. I could write it like that. doesn't really matter, does it? And the women are going to be the same. N women, 1 leader, and choose n times n. So then I've got n squared, n squared. Cool. What were we doing again? Oh, therefore, we just add them all up because they're different. So n 0 squared, 0 squared, plus n 1 squared, 1 squared, plus is that right? Oh, I've written it in the wrong order. And this doesn't need to be there. Okay. I'll go comment. Now the fourth part. Is this the last part? Yeah. The process is now reversed. So the leaders are chosen first, then the rest of the group selected. It's still made up of an equal number of men and women. Okay. It's asking for a simple expression for the sum. Nothing simple about that. I don't get why you multiply by n every time. Oh. Are you saying this one? Are you asking why I multiply by each of these? You could think of it like, okay, I've got one man in my group. Now I have to select a leader. So I want to select one leader, but I only have one person. So it's one, choose one. So that's why that's like that. And then if you think about this one, I've got n males. I've chosen 2 of them. Now out of the 2 of them, I want to choose one leader. And it's the same for the females. Now to choose one is just 2. And then the last one, I've got n men. I choose all of them. And out of those n people, I need to choose one to be my leader. And out of my n women, I need to choose one to be a leader. And that's just n anyway. Does that make more sense? I hope maybe. That probably leads better into why. So like this one, this is 0, choose 1. 0, choose 1. Which, what happens when you type 0, choose 1 in the calculator? 0, choose 1. Yeah, I got a math error. So that's probably why this isn't a thing. That would probably help for the next part. I guess I didn't really read the question then. I didn't really read. Oh, okay. Yeah, so it's basically like I've got a certain amount of men, and I need a leader for each group. So now we're going to go backwards, and I want to choose the leaders first, and then the rest of the people are going to be in my group. So for this one, I'll lay it out kind of the same. So how am I going to? So let's suppose I've got my full group of n people. So I'm going to write this. I've got, go with my group of 1. We'll go with my group of 0. So the group of 0. Now I have n men to choose from, but none of them are going to be in my group. So let's just, this is going to be so confusing. Men, I don't know how to lay this out. Okay, so m people, I'm choosing a leader. There's n ways of doing that. So there's n men in existence, and then what I do is I create my group. So I have n minus 1 people to now choose from to be the rest of my group, and I'm choosing none of them because it's a group of 0. So it's the same thing for the women. There's n women. So so this is my leader. So I have n women to choose as a leader. Then what I do is I create the rest of my group. There's 1 less of them, and none. Oh, this Seki just replied. And there's none of them in my group. So this one's meaningless. So just forget this one exists for a second. Let's go with the group of 2. So I select my men. I have n choices for my leader. Does this make sense why there's n first? Because I have this whole group, there's this big group of men, all of them. I select a leader, so I choose this bloke, and then out of all these people, I then decide what the rest of my group's going to look like. So I have n of them. Now I've got n minus 1 of them to choose from for the rest of my group, and I select one of them. And it's the same with the women. N of them, n minus 1. And this pattern kind of just goes on. So group of, I want to do a group of 4. Let's just keep going. So then my group of 2n, n. So again, I have n people to choose from. There's n minus 1 now for the rest of my group. And then how many do I want to select? I want to select, well, all of them. So n minus 1. Do you reckon this is a band 6 question because there's so many things to wrap your head around with? Okay, so then if I add all these up, so therefore total number of groups or arrangements, combinations, let's just do groups, is going to be, this first group is meaningless. I'll write that in this group. So that's n squared, n minus 1, 0 squared, plus n squared, n minus 1, 1 squared, plus, I forgot the n squared on the front. Is the leader counted as part of the group? The rest of the group is excellent. Yes. Oh, so then why would this be 1? Is that what you're saying? Oh, so that should be, that person's already selected, aren't they? I see, okay. So I've already selected someone, and now, okay, so this, it's this group of 0 that makes no sense. It's this one. Let's change that. That's our group of 2. So then 1 man is selected, and then there's no choices left for people in the group. I see what you're saying. Yeah, yeah. So then my group of 4 is going to have n. Yeah, okay. So then I've selected one of them. I have n minus 1 of them now to choose from, and I select another one. That makes sense. Yeah, it's the 0 group that is confusing. And then you already have to, yeah, that makes more sense, doesn't it? So if we went to our group of 6, we'd have n people to choose from for the leader, n minus 1 to then choose from, and there'd only be 2 spots left. Is that better? I feel like that's better. Okay. This is better. Okay, good. Then what can I do? I can factorize the n squared out. Is this to show that question? It's not. Okay, n squared outside of n minus 1, 0 squared, plus n minus 1, 1 squared, plus blah, 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 plus n minus 1, n minus 1 squared. And what you'll notice is, again, we've got all these terms that are just going up by 1, but they're squared. So if we go back to the start where we had 2n n is equal to 2n 0, no, n 0 squared plus n1 squared plus n, whoops. This question has taken half an hour. So if we just make a little bit of comparison, n minus 1, n minus 1, n minus 1. So it's like writing this, but with n minus 1 in it. So 2 n minus 1, n minus 1, would be equal to n minus 1, 0 squared plus n minus 1, 0, no 1 squared plus n minus 1 squared. Okay, so that means this, that should have been an aside. So, look, that's equal to n squared outside of 2 n minus 1, n minus 1. And I can simplify that by expanding. It's going to be 2n minus 2 n minus 1. A simple sum. Real simple. But that's two, so that's, that whole thing was 8 marks, and I've got 2 full pages of working out. I think that's pretty insane. Okay. How do you feel about that? I feel pretty exhausted about that. 17. Do we have time for another question? The game is played throwing darts at a target. Player can choose to throw 2 or 3 darts. Darcy plays 2 games. In game 1, he throws 2 darts. He wins if he hits it at least once. In game 2, he throws 3. He wins if he hits it at least twice. So he just has to miss once. That's the game, I guess. It's probabilities between 0 and 1, so they haven't told us what it is. Where the first one was to show that question because I don't. Yeah, well, yeah, because you'd be screwed for the rest of the question, wouldn't you? Okay, show the probability that Darcy wins game 1 is that. Okay, so the probability that he wins game 1, let's write this. Let's write what we want. We're required to prove the probability that he wins game 1 is 2p minus p squared. So that's what we want. So what does it say? The probability that he hits the target is p. So probability that he hits it is p, which means that the probability that he misses it is 1 minus p. I don't know why I put a bracket there. Okay, so what are the conditions that he wins the first game? It's he chooses to throw 2 darts and wins if he hits the target at least once. So the probability that he wins game 1 is equal to the probability that at least one hit. So he just has to hit it once. Okay, so whenever you see at least, that's 1 minus the probability of the opposite thing. So 1 minus the probability that he misses both of them. So both miss. The probability that he misses twice is probability that he misses, 1 minus, now the probability that he misses is 1 minus p. 1 minus p, 1 minus 1 squared minus 2p plus p squared. 1 minus 1 plus 2p minus p squared is 2p minus p squared, as required. Okay. First one done. Second one. It's going to ask me about game 2. So the probability that wins game 2 is that. Okay. So let's write what we want. We are required to prove probability that he wins game 2 is, what is it, 3p squared minus 2p cubed. Is that it? Okay. I love how these are all 1 mark as well. Like, anyway. Okay, so again, the probability that he hits it was p, and miss is 1 minus p. Now, for him to win game, why have you stopped drawing squares all of a sudden? What? Did I stop drawing squares? What? I don't know what you mean by that. Did I miss a square somewhere? I'll continue. When you finish proofs. Oh, sorry. Yeah, okay, fine. That's better. You're right. I don't know why I stopped doing that. Just as required seems so much more formal. I don't know. Anyway, what are the conditions that he wins the second game? He chooses to throw 3 darts, and he wins if he hits it at least twice. Ah. Okay. You kind of got to look at this one in cases because he's done it 3 times. So if he hits it at least twice, he wins. So that means he could hit it. If he hits it once, he loses. If he hits it twice, he wins. If he hits it 3 times, he wins. So it's the probability that he hits it twice plus the probability that he hits it 3 times. I hope that makes sense. Okay, so let's sort each of these out. So the probability that, let's go 2H. 2H, that's more condensed. The probability hits it twice. Okay, it's because it's like a binomial because he's got either hit or miss. How is this 1 mark? That's not very nice now, is it? Okay, so he's played 3 games. Let's call H hitting it a success. So he plays 3 games, he hits it twice. Now the probability, we got P and 1 minus P. Probability that he hits it, probability that he misses it. Okay, let's deal with this. What's 3 choose 2? Is it 6? No, 2. No. 3. God, I'm stupid sometimes. 3p squared, and then that's 1 minus p. So that's 3p squared minus 3p cubed. Okay. Now the probability that he hits it 3 times is going to be, we choose 3, p3, 1 minus p, 3 minus 3. 3 choose 3. There's only one way I can do that. P cubed, that's all 0. Okay, so that's just p cubed. So then this is equal to 3p squared minus 3p3 plus p3, which is 3p squared minus 2p cubed, as required. Square. Okay. Oh, I'm actually so late for a meeting. Screw it. This is way more fun. Prove that Darcy is more likely to win game 1 than game 2. Okay, that's a cool question. So I want to prove that his game 1 is greater than game 2. I think that's a really cool question. Surely. Okay, so game 1 was what? Let me move this over. What was game 1? It was 2p minus p squared. And game 2 was this. All right, let's move everything to one side and prove that it's bigger than 0. Let's just do it. 2p minus p squared minus 3p squared plus 2p cubed greater than 0. So that's 2p cubed minus 4p squared plus 2p greater than 0. It's divided by 2. Plus greater than 0. Let's factor out p. P outside of p squared minus 2p plus 1 greater than 0. We don't really need to consider the case where p equals 0. or p is greater than 0 because that's given. So I'll just write since it's greater than 0, given. Let's just omit that. Okay, two numbers are it's going to be minus 1 and minus 1, isn't it? P minus 1, P minus 1. Is that right? 1 minus 1 times 1. Yep. That's just P minus 1 squared. It's greater than 0. Okay. Since, how do I write this? P minus 1 squared is always positive. Therefore, P minus 1 squared is greater than 0. Therefore, 2p minus p squared is greater than 3p squared minus 2p cubed. Therefore, g1 greater than g2. Can't think of a better way. Can you divide by p since you can divide by p since p? Oh yeah, okay. Because 0 divided by anything is defined. Yeah. Either or. Okay. Alright, last one. Oh, which we don't care about, except for p equals 1. Yeah, exactly. Because we're strictly less than 1. Find the value of p for which Darcy is twice as likely to win game 1 as he is to win game 2. Okay. I think these are cool questions. So what are we up to? Find the value of p for which Darcy is twice as likely to win game 1 as he is game 2. So we want find p when game 1 is equal to twice game 2. That's always confusing to set up. It's twice as likely to win game 1. So that's 2 times game 2 is game 1. Okay. Alright, we'll substitute. What were the values again? 2p minus p squared equals 2 outside of 3p squared minus 2p cubed. Let's just expand that. 6p squared minus 4p cubed. I guess I'll set that equal to 0. Let's move stuff over. 2p minus p squared minus 6p squared plus 4p cubed equals 0. 2p minus 7p squared plus 4p cubed equals 0. Take a p out again. P outside of, let me line these up, 4p squared minus 7p plus 2. That ain't factorizing nicely, is it? Surely. What do you reckon? Do you reckon that factorizes nicely? Well, we don't care. P can't equal 0. So that's nice. Quadratic formula, what do you reckon? Do you reckon that factorizes? I'm going to take a punt and say surely not. P equals minus b plus or minus the square root of b squared minus 4 times a times c all on, wow, that was terrible, all on 2a. 7 plus or minus the square root of, okay, what's that? That's 4 times 4 is 16 times 2 is 32. What's 49 minus 32? 17. Square root of 17 on 8. Square root of 17, certainly not nice, so I guess we'll just leave it like that. I don't think so, yeah. Neither. Oh, one of these is going to be negative, isn't it? So this equals 7 minus root 17 on 8 is 0.3536. And when it's plus, it's 1.39. Oh, okay. So that means minus root 17. Okay. Since P is between 0 and 1. But positive case is greater than 1. Yeah, nice. A lot of easy mistakes to fall into there. That's not worth that many marks. 1, 2, that was 6 marks for that whole thing. What do you reckon the band 6 components? 16. Yeah, so look at this last question. 26%, 26%, 26%. This one, 47. So less than 50% got the first part right. 40% got the second part right. 21% got... Oh, this is what I was saying. So many students multiply the wrong side by 2. It's always confusing trying to set this up. Most people get that right. 21% got that right. Okay. Yeah, I almost forgot that. That's an easy... Yeah, right. Okay, well, I'm going to talk to Miss Sankey and figure out if Greg and Quang are going to do extension 2. That's pretty exciting. But other than that, I think we're good. Let's do... What should we do next? Have we done these? What did we just do? 16, 17. It always feels a bit unintuitive setting up questions. Yeah, that's what I think, because it feels wrong. It feels the opposite. So we'll do this one. A little slick, and yeah, projectile motion. Cannonball fire from a castle. Looks exciting. All right. Let me know if you get your advanced marks back too. But yeah, I'll see you same time Thursday. Have a good take it easy Tuesday. And I'll see you then.